Good morning. Are you audible?
Yes, sir.
Yes, sir.
Okay. Okay. Good morning. Today we discuss about the pulse triggered flip-flops. The pulse triggered flip-flop, the most important thing will be the master slave concept, flip-flop concept. Before to discuss the detail about the pulse triggered flip-flop, and even I will discuss about the level triggered also. We must know once again the little bit discussion about the flip-flop on that SR, JK, not T and D. What is the problem in the SR flip-flop? Want to go for JK?
Forbidden case.
Forbidden case. At least all must to know the S and R should be 1 1, which you cannot consider in SR. You can treat it as an invalid output or the forbidden output. The output will be maybe 0 or a 1, which it will continuously changing. That will not accept or match with your required output. Means SR11 case, you are not at all considering the output. That is the problem only. That has to be overcome by the JK flip-flop. It's okay. The JK flip-flop even acts as SR only. 0 case retain and 0 case will be reset and 1 case will be set and 1 case will be toggle. There in SR it was illegal or forbidden, which it will be overcome by the JK flip-flop, that will be toggled case. It's okay. Toggled means if the current input is whatever it is, which it will be complementing. If it is 0 and you will get 1, and if it is 1, you will get 0. But one more problem is there in the JK. The JK problem is if the pulse time, it's okay, clock, pulse is the clock here. Clock time is more than the propagation delay of the hardware. Hardware here it will be the flip-flop. Then that much time means that pulse time, that clock time, output is continuously toggled. Output is continuously toggled. I'll give an example for that. If I want to see you in the classroom, just not more than 1 second or 2 seconds, possible or not, yes it is. Then I can see you only condition, either in sitting mode or a standing mode. How much I spent a time to see you in the classroom? Just 1 second. 1 second, what best I can see you? You can in sitting mode or a standing mode. If I see you in a period maybe a minute, you take 1 minute. And you are allowed to stand up and to sit in any time. That is also there. That condition is very much important. Then in a 1 minute of period, can I see you all time in sitting mode or maybe in standing mode also? Audible? Hello?
Yes, sir. Yes, sir.
You are allowed in the class stand up and to sit continuously. If I spend a minute of time while seeing a one person or one student, can I see you in only sitting mode or standing mode or once again in sitting mode? Are you audible or not first? See, you are not to sit in the class. See, take an example, you are not to sit in the class. Just 10 seconds you have to sit and 10 seconds you have to stand up. 10 seconds you have to sit and 10 seconds you have to stand up. If I see you in a 1 second, it's okay, or maybe 2 seconds, I can see you in only condition, either may standing mode or maybe in a sitting mode. If I see you in a minute, can I see you in only condition for sitting or standing or continuously sitting and standing?
Continuous sitting and standing.
Continuous.
Sitting and standing. Itself will be the toggle case. How much time I am seeing is very much important. That is pulse. If I am seeing you just 2 seconds, 2 seconds is less than the allowed time. How much time I told you to sit? 10 seconds. How much time I allowed you to stand? 10 seconds. How much time I spent you to see? 2 seconds. My pulse time is less than the allocated time. That time I can see you only either sitting mode or the standing mode. Then I don't have any problem. But if my time elaborates, changes to 1 minute, means my pulse time is more than the allowed time. Allowed time is just 10 seconds. Now I am seeing you for a minute. In a minute, you are not in the same position. You are sitting 10 second, standing 10 second, sitting 10 second, standing 10 second. This is toggling case. But I want either you should be in sitting mode only or you should be in the standing mode only. Then what should the design has to change? It's okay. What the design has to change? One thing is my period has to reduce. What I am seeing, you know, I must to reduce that. Pulse time has to reduce. This is one case. And second case is when I see, then you should not change the position, sitting to standing or standing to sitting. How long I am seeing, you should be in the same state. In this, it's okay. Concept only to see you in the current state. Are you accepting or not?
Yes, sir.
Got no? These two are the cases. Important cases is either I have to change my time or I have to design you. Design you means I will say you. When I say any student, whatever the condition he is, he should be till I want to see him in the same status. When I left that, afterwards whatever he can do. This is the change for the design. To do that, you should have to change the concept, design concept. For that case, they went for master-slave concept. It's okay. The toggling problems has to be taken care by in master-slave concept. It's okay. Then second one is, what is pulse-triggered concept, what is edge-triggered concept, what is level-triggered concept. These three must to know. Pulse is just one pulse from low to high to low. Low to high, next to low, one pulse. Or maybe high to low to high. This is one pulse. One pulse may be high pulse. High pulse, how you can call? Low to high to low. Low to high, next to low. This is one high pulse. Then how can you say low pulse? High to low to high. This is one low pulse. It's okay. Then when you want to changes in the input for the period of high pulse or maybe a low pulse, the changes will occur or the process will took place and the output will change. Where it is in pulse triggered. But in edge triggered, only in the high edge means the rising edge or maybe in the falling edge, low edge. The output will alter. See the difference between pulse triggered and the edge triggered. A pulse, in a particular pulse, it's okay. When you are taking this to the low to high pulse to low, then the low to high to low pulse, only the changes in the input has to be taken care by the designed block, and which it will alter the process and provide the output. But edge triggered is not like that. Edge triggered is you can take either passage or an egg edge, rising edge or a falling edge. The only particular edge the process will take place. Then what is the difference between these two? Pulse triggered will elaborate more time. It's okay. But edge triggered will allocate a small amount of time. Then which is efficient? Edge triggered is efficient. It's okay. Then which is good one? Depending upon application. Depending upon the application. If my application is need more time to changes, then pulse triggered you have to prefer. You should not allow for more changes. Then it should be specific. Then you can go for the edge triggered. I can give an example for that. Your result. If your result is based on marks, if your result is based on grade, which is good? Or to whom? Audible?
Yes, sir.
Your result declaring by the VTU based on marks, based on the grade, which is good?
Based on the marks.
Marks. Who is saying this one? Whom is very much important? If he is above average student or distinction student, what he will say? Sir, based on marks is good, sir. Because anyhow he will be scoring more than 80, 90. He don't want to touch anyone because he should be say specific. But one who are less than below average, what they say? Grade is good, sir. Because the 31 is same as 39. 31 is same as 39. 41 is same as 49. 51 is same as 59. It's okay. Then what he is saying, sir, I want at least wherever I am, I can say at the top. On that top. It's okay. Whom is very much important. Which application is very much important. It's okay. This is the pulse triggered concept. I will read out. Pulse triggered flip-flops. Pulse triggered flip-flops are also referred as the master slave flip-flops. As we know, the problem for race run-out condition, which comes in a toggling at the output of the JK, has to be overcome by the master slave concept. There are several applications where it is undesirable that the output of the flip-flop and latches responds immediately to changes in the input. Some of the applications, what they will expect, any change in the input, immediately the output has to be necessary. It's okay. If any change in the input, immediately the output has to change. It's okay. But this is undesirable in pulse triggered. This is undesirable in the pulse triggered. It's okay. Then whenever you are assigning it to an edge triggered flip-flop, at that time, what you can say, it is a problem at the output. Then it is desirable that the output changes only with changes on the control input line. It's okay. Without the control input line change, you cannot expect the output has to change. The output of pulse triggered flip-flops or edge triggered flip-flops respond only when changes takes place on their control input line. See, the output of pulse triggered flip-flop and edge triggered flip-flop responds only when changes in the control inputs. Control inputs, here you can take it as a clock. Whatever the changes in the input, flip-flop will not respond for that. When the flip-flop will respond? Based on the clock. How is the clock? Pulse triggered? Yes. With the particular pulse, the output will change. Edge triggered? With the particular edge, the output will change. What way you can understand? The output of the pulse triggered flip-flop and the edge triggered flip-flop response means to change only when changes in the control input. Control input is the rising edge, falling edge or particular pulse. It's okay. Take one example, JK only. J is changed, K is changed. Is output changed? No. How can you say, sir, output is not changed, even input is changed, J and K? Can the control input is altered? No. Then output will be retained. When control changes according to the requirement, that is very much important. Control changes according to the requirement. Take an example, which is control? Clock is the control. Clock changes according to the requirement. I want the positive pulse. Positive pulse occurred, output changes. I want the rising edge. Rising edge occurred, output changes. I want the falling edge. Falling edge occurred, output changes. Even control signal also, what you need, which you will not get, then it is very difficult to expect the output change. Any doubt in this? Are you audible?
No doubt, sir.
Are you audible? See, if a flip-flop is there, either maybe SR or a JK, it's okay. When you want to change any inputs, the output you cannot expect to change. When the output will change? Based on the control input. Which is control input? Clock. When clock changes, only you can expect the output change. Whatever clock I am taking, as I told, no, it may be pulse triggered. Which pulse? Positive pulse. Or maybe negative pulse, which you can say it as a 010 pulse, positive pulse, negative pulse, 101 negative pulse. It's okay. Then rising edge 0 to 1, falling edge 1 to 0. In all four cases, only you can expect the output change. This itself will be the control signal. Next, pulse triggered master slave SR flip-flop. It's okay. You can build a master slave flip-flop based on SR or based on JK also. It's okay. One, we can go first for the master slave flip-flop based on the SR. You can see here. Figure shows the master slave SR flip-flop configured in two gated SR latches. You can see here, this is one SR flip-flop and this is another SR flip-flop. The first SR flip-flop, S will be the S input and R will be the R input. And Q and Q bar is there, no? I am writing, it's named as a master, QM and QM bar. My QM is next SR flip-flop S. My QM bar is next SR flip-flop R. And the clock is given in which fashion, that is very much important here. To get the right output in the 1-1 case. See here, clock directly given to the master and you have a one NOT gate is used and connected to the slave. Means in one pulse, master is working, another pulse, slave will work. You take one clock will be high, one high pulse and one low pulse. What is one cycle? Audible?
Yes, sir.
Are you audible? What is one cycle? See here, one cycle is one high pulse and one low pulse. It's okay. High pulse is performing by the master and next low pulse the slave will perform the operation. It's okay. How the master slave is connected? Master is one SR, slave is another SR, and the clock is connected for directly to the master and with one NOT gate the slave is connected. Means passage master works and negate slave will work. And how the cascading fashion is Q and Q bar, that is QM and QM bar. Why I use the suffix M? Master outputs. Why I use the suffix S? Slave outputs. Master output M is S of the slave. Master M output complementation will be the R. Slave input R. And see the SR condition. This is pulse triggered as I already told. It's okay. When clock is 0, I can go for the last condition, truth table, that is function table. When clock is 0, whatever the condition of S and R, what should be your Q plus? Q plus is next state. What should be your Q plus? Are you audible? Connected or not? That is retain case. Very simple retain case. It's okay. Memory indicates that it has stored some information. You have not at all changed, means when you are expecting that one, the same is available on the area. It's okay. You take one example, I kept 500 rupees in my wallet. I have not at all used that. When I opened my wallet, am I getting it or not? Yes, that 500 currency is available in my wallet. This is same. It's okay. When clock is 0, whatever the condition of S and R, it's okay. And Q plus should be Q only. Now you see here, clock is given. Which type of clock is given here? Which type of clock is given here?
Edge.
Are you audible? This
Yes,
is
sir. Edge.
edge. Okay, I want to clear you much more on that. There is not edge. Edge I will show you. It's okay, edge I will show you. This is pulse. See, edge is a very small amount of time. Rising time or a falling time is an edge. In this you have a two edges. It's okay, I will show you here. Are you seeing my cursor? Cursor point?
Yes, sir.
Hello? Okay. See where the cursor is now? Low to high edge. This is low and this is high. Low to high edge. This edge will be the rising edge or passage, positive edge. And from 1 to 0 is the falling edge or negative edge. The whole, so okay, pulse will be the positive pulse. One is the pulse triggered. This is whole pulse is there. Pulse timing is much more than the edge. I told you already. When you use the pulse triggered, accuracy will be degrading. It's okay. When you went for the edge triggered, definitely the accuracy will improve. What is that accuracy? Allocation time. It's okay. Allocation time. If I want to see you and to talk, how much I want to see you? Minute you have to see and minute you have to talk. Then half an hour class I took. What is the actual class I took? 15 minutes. Because 50% I want to see you and 50% only I want to take class. Is it okay? No. I don't want to see you much more. What I can do? I can reduce that. 10% I can see you, 90% I can talk. It's okay. Then 90% efficiency, 10% only loss. Why do see you? What you are doing, at least I can have it continuation. Otherwise, whatever the outcome will be treated as zero. It's okay. I can connect for an example here also. Several times I am using are you audible? Am I doing it or not?
Yes, sir.
Yes, sir.
Are you audible? See, why I am doing that? Are you audible or not? Why I am using that word repeatedly? Are you audible or not?
To check whether we are active or not.
That is very much important. It's okay. Otherwise, whatever the class I took here is waste. Outcome is zero. You were not at all here. At least how many people will connect? No, I will come to know that these many people are active. It's okay in enable mode. And the question comes here is, if I use as many times, at that time, am I taking class or simply I am connecting you to either you are live or dead case, or you can say active or inactive case. If I use once or twice or 5 times or 10 times, okay. If I use every word, are you audible or not? Then class will be covering more portion, or simply I can check you for either you will be in active or inactive state. Are you getting? Are you audible once again?
Yes,
Are you
sir.
audible?
Yes, sir.
Yes, sir.
See, if I am continuously asking, are you audible? I am losing time. It's okay. My class is 1 hour. 10 minutes I asked only for are you audible or not. Then how much the actual class I took? 50 minutes only. Then what should I do? I can reduce that. It's okay. I can reduce that. Reducing is this pulse, you can see here. Full pulse, you are need not necessary. Then pulse time you have to go on reduce. When you are reducing the pulse time, very much important thing is that whatever the work you have assigned to perform the operation of the circuit, that is the propagation delay, should be match. Should be match. You take one example. Today I want to highlight my questions, second assignment questions. How much time I supposed to give to get the 100% efficiency? What is your opinion? This is an example. Today I am announcing the second CIE assignment questions. If I want efficient result, what is that efficient result?
Sir,
100%
3 to 4 days, sir.
efficiency.
3
to 4 days.
Okay, repeat. Tell me, no problem. 3 to 4 days. 3 to 4 days is 100%. If I have given 5 days, are you submitting it or not? Yes. But is it 100% efficiency? No. Efficiency degrade. It's okay. That is one. Second one is, if I have given you 10 minutes, just I am giving you 10 minutes. I have uploaded the Google Classroom. After 10 minutes, I want the result. Are all submitted? No. Outcome fail. Means I must to know, or I must to calculate how much time exactly needed. Only that much I am supposed to provide. If I want to give you an example, you add 2 plus 2. I want the answer. How much time I am supposed to give? 2 days. How much time I have to give? Just I can give you for 5 seconds. Because my questions are single digit additions. Single digit addition, you can add it and to display the result. It's okay. That 5 seconds is more than sufficient. Then as many questions has to be covered by a minute. Otherwise, if I given more time, the questions covering will be less. Then efficiency degrades. Then what we come to know all? whatever the amount of time needed, we should have to calculate exactly the same amount of time you have to provide. Is it? Then efficiency will be improving. This is exactly same. When I am giving this pulse, when I am giving you this pulse timing has to be so exact. Then what should you have to do? You go on reduce that. You go on reduce that. When you say, sir, less than this, we cannot do that. I can stop. I can stop. Then I will get the better efficiency. It's okay. I will connect this to an example. I have given assignment. I am giving you 8 days. Then someone will say, it's okay, 8 days is more, sir. Then I will reduce 7. Then I will reduce 6, 5, 4, 3. Then I came at 3, someone will say, sir, if it is less than 3, I am unable to complete and to submit. Then I can stop. Then I can stop. Then what was I have given initially? 8 days. How much it has reduced? To 3. Then less than 3, I may not get 100%. Then I can stop. Then if I have given 8 days, unnecessary time. Then if I have given 3 days, efficiency will be more. This is the way you can allocate the time. It's okay. That is the pulse. Then you can see for an SR00 pulse is there, Q plus will be Q. SR01 reset is there, Q plus will be 0. SR10 set is there, Q plus will be 1. And SR11 not, it's okay. Means that is forbidden you can say, or illegal you have to say. This is the truth table, everyone know this. And one thing in this case, master slave, whenever you are considering, the clock amount is very much important. It's okay. The clock amount is very much important. You take an example for the clock. The clock here, it will be initially 0, slave is enabled, and high master is enabled. It's okay. When master is enabled, slave is disabled. When slave is enabled, master is disabled. That is very much important, because I will show you back once again this one. How the clock is connected for master and a slave? Opposite. When clock 1 for master, the same clock is connected for the slave will be complemented fashion. When clock is 0 for the master, the complemented fashion will get to the slave. It's okay. Then when master enables, clock disables. Then master disables, then slave will be enabled. But one thing in this case is this period you can see. Clock is 0 and clock is 1. Not in the same time. That is sure. I'll give an example for that. At 9 o'clock, it's okay. You will be in classroom. It's okay. At 9 o'clock, you will be in your house. True or false?
Sir.
False. Because 9 o'clock you will be in classroom means at 9 o'clock you cannot say I am in my house. It's okay. Then how much is the time you needed from your house to this classroom? That is the lapse time. Time needed to reach. This is same. You can see here. When clock is 0 and clock is 1. When clock is 0, clock is 1, levels are there. Clock 0, 0 volt. TTL compatibility. Clock 1, 5 volt. Transistor logic compatibility. It's okay. In this case, when you want to move from 0 to 1, how much time is needed depending upon the design? But I can say at T0 I am in 0, at T1 I am in high. Then T2 minus T1 is the time needed to change from 0 volt to 5 volt, or logic 0 to logic 1. In this case, you are writing with levels. It's okay. Threshold levels you will be writing. I don't know how best you will be understanding by the threshold levels. Threshold levels will be learning it in the next continuation. Means 5th semester or maybe in VLSI. No doubt you will be studying thoroughly. But 0 is not the only logic 0. Are you accepting it or not? Are you audible? Are you audible?
Yes, sir.
See, 0 volt is logic 0 and 5 volt is logic 1. When I say this word, is 0 volt is the only logic 0? Digital system design, it is okay. But when you went to a Nalaga design system, you cannot say only 0 is logic 0 and only 5 volt is logic 1. Then that is ideal design. Ideal design never you can expect in the market. What is that ideal design? Sir, I am 9 o'clock in classroom and I am 9 o'clock in my house. Is it possible? No. Then what should you have to say? Ideal design never comes into the market. Which market? Worldwide market. Not to think only for Bijapur market. Is it? See, then which is logic 0? Logic 0 you can say 0.1 volt, 0.2 volt, 0.6 volt, 0.7 volt. Then you should have a threshold designs. When you say 0 is 0, 0.7 is also 0. Then 0 to 0.7 is one band. You can treat it as a logic 0. Then 5 volt is logic 1. No sir, even 4.3 also I can consider it as a logic 1. Then 4.3 volt to 5 volt is logic 1. Then you have a two bands, not only value. 4.3 to 5 volt logic 1. 0 to 0.7 is logic 0. Then what is 0.7 to 4.7? Unband. Unband meaning is if you have a value, you won't consider that. It's okay. Then you cannot expect any changes for that. You cannot expect any changes for that. Then design, it's okay. When design goes on reducing the timings. Take an example, 0 volt to 0.6 volt, one more design came. That is good design. 0 volt to 0.5 volt is logic 0. That is better than the previous. 0 volt to 0.3 is only 0. That is too good design. It's okay. Similarly, you have a logic 1 is 4.5 to 5. Good. 4.7 to 5. Compared to this, this is good. And 4.9 to 5. This is too good. But you have to have the other problems also there. Unband is increasing. Unband increasing is any changes in the input, you may not expect the output. Output is blurred. Then even less efficient design, the outputs you can expect, then band has to be expecting more. Band has to expecting more. It's okay, that acceptance is very much important. Why FCD is written 70%? Why passing is made now 22? Do you have any idea? Audible?
Yes, sir.
Why it has made? Why 70% FCD and 22% passings? What is the reason? Only to accept the students. It's okay. Passing may can put to 50. Good or bad? Both are there. Good is in one sense, you will get a good quality output. Bad is one sense, it's okay. You are rejecting as many students. Am I right or wrong?
Right, sir.
If I am talking based on the quality, see, if I am talking based on the quality, 50% passing, output is good compared to now. But what is the problem? You are rejecting as many students. That is not good. Both are there. Where you are taking, that is, it's okay. Very much important. Now what I am doing, even distinction also. Distinction 70%. Now all are distinction. In Karnataka University, particularly, no one will be above 60. That time distinction is rank student. But now all are distinction. Then there is no value of distinction. Then what should you do? Change the distinction marks. How much you can put? 85 you can put. 85 you can put. Or 90 you can put. Distinctions are more or reducing? Reducing. Then what is the quality? Improving. Above 85% strength will be less. Or above 90% strength will be less. Or you can say good quality is there. But what is the another problem? So many people lost the distinction. That is a drawback. Both are there. Where you are applying, which one it will consider, that is very much important. Like here, clock you can see here, clock, only 0 is not a logic 0, only 1 is not a logic 1 in the analog concept. You should have a band. Therefore, you see here, Slave enabled till T1. Is T1 is 0 or above 0? See my cursor.
Above 0, sir.
Then above 0 is treated as 0. Good. It's okay. Then master is enabled. Master is enabled at 5 or less than 5. T2 you can check here. 5 is my cursor. T2 is before that. Good or bad?
Less than 5, sir.
Less than 5. It's okay. Then master enabled. It's okay. 1 it will be 1. But it has enabled before 1. 1 is 5 volt, logic 1. Before 1, you take 4.7 volt. Good. Then see band. This 2 cross are there, no? This is a band. Band goes on reducing. Acceptance will be more. Reduce the marks. 10 marks pass. Almost pass. 90 marks pass. Only 10% pass. Or you can say only 1% or 2% pass. Both are good. Quality based 90 is good. Acceptance based 10% is good. Here also exactly same. It's okay. At least you could understand in this pulse. It's okay. Pulse needs the time to change the logic 0 to logic 1. 0 is not the only logic 0. Above logic 0 is also logic 0. But how much it is deciding by the design? Like even high is not the only the logic 1. Less than high is also a logic 1. How much it is based on once again the design. This is about the concept of clock. Do you have any doubt? You can ask me. I will explain once again the detail. Even this one I will send you. Okay. Then I will apply this truth table for the circuit, and I will expect you to know. What is case 1? Case 1, when C equal to 0, the master being gated SR latch is disabled. Are you accepting it or not? When C equal to 0, I will show you this figure. When C equal to 0, it's okay. Master will enable or disable? Passage, eh? Okay. Master clock, what you will get? When C equal to 0, master clock, what you will get? 0 or 1? Master clock is 0. What the master clock you will get? 1 or 0?
0, sir.
0.
0.
See my statement itself it is there. Master clock is 0. Master clock gets 0 or 1? 0 only. I told you in the beginning only master clock is 0. Master clock is 0. What the clock you will get for the master? 0 only. Then here one not gate is there. What should be the clock of the slave?
1.
1.
1. It is a complementation is there. And master clock 0, slave clock 1. And master clock 1, slave clock 0. Very simple. Not to confuse that much. It's okay. Master clock 1, slave clock 0. Master clock 0, slave clock 1. Simple. Complementation is there. You have a not gate here. Now case you can check it here. When C equal to 0, the master being gated SR, it is disabled. As you had an idea, when SR clock is 0, can expecting an output change? No. It's okay. No. It's okay. Then what you can say? It's ignored. Inputs, whatever changes has to be ignored for an SR. It's okay. At the same time, the slave is enabled. Why the slave is enabled? Master clock is 0 and slave clock will be enabled. Due to the presence of the current state, see here, I can show you the figure. QM and QM bar are there because it's a memory block. When you are not given a clock, the content is there, master content is there or not? What is your opinion? Not got. S and R is 0, 0, or you can say 1, 0. S is 1, R is 0. Are you audible?
Yes, sir.
Yes, sir.
Are you? Oh, S is 1, R is 0, clock is 0. What is the output?
0.
Q, sir.
Q. Who told Q is right? That is previous. That is retained case. See, when clock 0, whatever the condition of S and R, the output is not changing. The output is previous only. That is the past history. Are you accepting first? When clock is 0, whatever the condition of S and R, the output will be Q only. It's okay. What is that QM? Q only. Similarly for even slave also. Similarly even slave also. Now I will ask you, when clock is 0, initial value of the master will be 1. Initial value of the master is 1. It's okay. Concentrate this one. Keenly you have to concentrate. What is stored in the master output? 1. S and R both are 1 and 0. Clock is 0. What should be QM? Are you audible?
Q, sir.
Are you audible?
Yes, sir.
Hello? Are you audible? Yeah, this master memory is stored 1. How much bit this SR flip-flop can store? Yeah, how many bits SR flip-flop can store? Yeah, one flip-flop can store 1 bit. At least you should know this one. One flip-flop can store 1 bit. If I want to store 5 bit, 5 flip-flop have to cascade. Next you will learn this. When you want to build the design of register, when you want to build a design of counter, it's okay. That time you will come to know. How many bit each flip-flop can store?
1 bit.
Yeah, how many are connected? Can I see at least? I can see at least how many are there. 60 are there. See, 72, now 60 are there. I'm very sorry, if such attitude is there, you never change. Very sorry for that. I told you, supposed to be here. Come to college. Connect to staff members. With whatever you know. $60 are just here. How many bit you can store in one flip-flop?
1 bit, sir.
1 bit.
1 bit. Now I am storing for master 1. 1 bit, that is 1. I can store only 1 bit, which you can store either 0 or a 1. I am storing 1. It's okay. Now SR is 1 0. Clock is not given. What is Q?
1, sir.
Tell me. Now I am supposed to start in Kannada. And we are not at all understanding this one. I am putting 500 rupees in your wallet. It's okay. Then, without my permission, no one can open that. That is clock. Clock 0. It's okay. How much I put? 500 rupees. Initially, nothing it was. 500 rupees I put. Clock 0. My question is, how much currency in the wallet?
500 only.
How much currency in the wallet? 500 only. Because clock 0 is not allowed to open. Not allowed to open means you cannot take it and you cannot put it. Very simple concept. Clock is not allowed. S and R, whatever it is, maybe 10 or 01 or 00 or 11, does not matter. What Q was, Q will be. I told no, Q is 1. Clock is not given. Yes, sir, I am giving you to 10. What is Q? 1 only. Clock 1 only alter based on the condition of the inputs. Clock 0 does not matter. Can I repeat the question? Master flip-flop, master SR flip-flop I can store 1. Store 1 means Q is 1. Store 1 meaning is available. Q is 1. SR is 1 0. Clock is not given. What is Q?
1, sir.
1, sir.
1.
1. It's okay. What is QM? Fast.
1.
Hey, Q is QM. What was Q? 1. QM is 1. Q is 1. QM is also 1. Are you seeing this one or not? Image.
Seeing, sir.
Yes, sir.
Yeah, are you seeing this image or not? When Q is 1, QM is also 1. What is QM? Yes. Slave input.
Yes, sir.
Yes, sir.
S is 1. S is 1. If QM is 1, QM bar is how much?
0, sir.
0.
0.
0. S is 1, R is 0. Means QM is 1, QM bar is 0 means S is 1 and R is 0. Are you agreeing?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, clock is 0. Where? Master. What about slave clock?
1.
1.
1.
1.
1.
Slave clock 1. Immediately it takes the input. So what is the input? What is the input?
1, 0.
1 0.
1 0, not 0 1. 1 0. S is 1, R is 0. Clock got. And clock is 0 for the master. Clock is 1 for the slave. Then slave gives the output. What type of output is? What is QS?
Q.
Now you see S is 1, R is 0. Clock is available. What is QS?
1, sir.
1.
Sir. 1, sir.
1. Because it is a set case. Because it is a set case. See, initially I can store for master 1 and I can store slave 0. It's okay. When clock is applied 0, master will not work but slave work. And slave will provide the result. It's okay. Similarly, when master works, slave is inactive. When master inactive, slave will be active. It's okay. Why we took this connection? Why you took this connection? The problem for the race condition, race around condition. What is exactly the race around condition? As I already told, no? When pulse is high, that is too much. The propagation delay is less. Then the output will be changing 0101 case. That is race around case. Then I want to reduce that. What should I do? I take for the SR latches 2 and allow for a master and allow for a slave. And 50% timing I can allocate for the master and 50% time I can allocate for the slave. Master pulse will be 1 and slave pulse will be 0. It's okay. In a one cycle, 50% time I reduced. Then hope the best. It's okay. The master slave flip-flop will give you the right result at the output. What is that meaning of right results? Toggling will not take place a period of a pulse. Toggling will not take place in a period of a pulse. That is pulse triggered. But I can tell you for the edge triggered, no chance for the edge triggered, you can. If your edge is only low to high or high to low for master as well as the slave. See, I can read out here. When C equal to 0, the master being gated SR latch is disabled and any changes on the S and R inputs are ignored. At the same time, the slave is enabled due to the presence of the inverter. Hence, the slave is in the same state as that of the master. Since QM and QM bar outputs of the master are connected to the S and R input respectively of the slave, as control signal starts to rise, the slave is disabled at time t1 while the master remains disabled. It's okay. When the slave will disable, slave control signal will be reduced to less than the how much? 4.3 volt. Logic 0 actually starts with 0.7 volt. But logic 1 will be 5 to 4.3 volt, less than 4.3 volt, unbanned. Unbanned is disabled by the slave. But have you entered the master? No. Thus the slave becomes disconnected from the master, but relation to the state of the master is, once again it will be continuing. The control signal continues to rise and it is at time T2 that the master will be enabled. It's okay. I will show you once again here based on this. When master will be, when the slave will be enabled from this to T1. When T1, immediately the slave will disable, but till T1 to T2, master and slave will be in disabled state only. When the master start to enable? After T2. After T2 you see here. Then even the master will enable not only the 5 volt till T3, but till T3, it's okay. What you can say? Master will enabled and slave will be disabled. But what about T3 to T4? Both are in unconditional state. Then after T4, you can say your slave will enable, but master automatically it will be disabled. It's okay. Try to understand the concept of this single pulse. I can say here, slave enable up to T1, then master enable after T2. But T2 to T1 unconditional state. Then how long the master will enable? Up to T3. It's okay. Then what up to T3, what is the condition of slave? Disable. But after T4, slave enabled, master disabled. But between T3 to T4, unconditional state. What it was will be retaining. This is the concept of the pulse and the pulse triggered flip-flop. Based on this condition, the timing diagrams we supposed to go. One cycle, one high pulse and one low pulse. One high pulse master will enable, one low pulse the slave will enable. In a single cycle, master and slave will enable, and it could be reduced the timing also to get the proper output in the race around condition. And I will show the images for this. I'll show you this. Logic sync of the master slave flip flop SR. This is S and R. It's okay. And you have a Q bar. And how to alter master slave SR to JK? How you have changed for SR to JK? I can show you here, the beginning. This is for SR is there. How you have changed from SR to JK? Gated logic. Gated SR is the JK. Gated SR is the JK. I will show you the connection. See this one. SR I used, gated SR I made at that one. Just I made that to gated SR. It's okay. The Q bar is connected to the one AND gate with one input is J, 2S. Similarly, Q is connected to the one AND gate and K you have connected another input and the output is connected to the R. And clock is given same. It's okay. You have used two AND gates and one input is changed from SR to JK. Another input is, it's okay, S and Q bar. Similarly for Q and K. This connection will made changes to SR master slave to JK master slave. It's okay. But SR master slave is always problem. Why SR master slave is always problem? One case. Then if you want to make that to JK master slave, even all the cases you will get the right result. It's okay. That is very much important. This is one point you must know. Do you know it or not? Are you audible?
Yes, sir.
SR master slave, one case problem is there. That has to be overcome by JK master slave. Is it? See, truth table of the JK,
Yes,
as you had an idea. JK 00 with the pulse, Q plus will be Q. 010, 101, and 11 will Q bar. 11 will Q bar. And clock is not available. Whatever JK, Q plus will be Q. See the table. This is the function table, or you can say the truth table, as already told. It's okay. This is already given data is there, discussed already. This is explained by J equal to K equal to 1 when Q equal to 0, QR equal to 1. The output AND gate is 1 and equal to 1. This is already explained. This explanation I already given. It's okay. Just at that time I took only single connection of the SR and I have made that to JK and which it is explained. But only thing in this case is I can tell you to clarify. Positive edge, concentrate this one. Positive edge JK treats the master inputs. Negative edge, it's okay. Negative edge QM and QM bar treats, it's okay, the next block inputs. Try to understand here. Positive edge pulse, JK took the input and execute the master block and got the output for QM and QM bar. It's okay. And in the negative edge, that QM treats as S and QM bar treats as R, and taking with that clock, and you will get the slave output. Yes, QS is slave output and QS bar is slave output bar. It's okay. That is explained here. And timing diagram you have to concentrate. The timing diagram I supposed to take a new one. I can go for the, just wait. I can go for see here. Okay, are you seeing the waveform of the master slave JK? Audible?
No, sir. Function table.
You are seeing function table.
Yes, sir.
Which one you are seeing now?
No, sir.
One second.
sir.
Hello.
Yes, sir.
Yes, sir.
Okay, you see this JK flip-flop? JK is drawn and K is also drawn here and clock is given here. What you can see in this positive clock, it's okay. QM changes you can expect. It's okay. Positive clock, QM changes you have to expect. It's okay. In the negative clock, you take this QM and QM bar are the inputs and write the QS and QS bar. Concentrate here. J and K you can take as the input for positive clock edge. Concentrate. J and K are the inputs you can take it for positive clock edge. This is for the master and you will get the master output. When you got the master output, immediately you write the master output bar. Now master output and master output bar are the inputs of the slave. Where you supposed to connect the slave? Negative pulse. See, this is the negative pulse. Negative pulse means 101. Positive pulse means 010. It's okay. See here, I can see in this case, whenever you have a clock, that clock conditions you can check it here. With a particular positive clock edge, what is the value of J?
1, sir.
What is K?
0, sir.
See the cursor, 0. Set case, reset case, retain case or toggle case, JK. JK function table you know.
Set, sir.
Set case. Set case means whatever the output should be 1. See, whatever QM is the output, no? Whatever the output at a particular time should be 1. Is it? See, initially I took QM will be 0 in a particular pulse, which positive pulse. Based on the input, the output changes from 0 to 1. Is it okay?
Yes, sir.
Then, like QM you have to write first. With the JK you can take it and to write the QM first. When you return the QM bar also you have to write. Where you have a 1, 0, where you have a 0, 1. QM bar also you have to write. Next, what you can do, the same clock you can consider for the negative pulses. In this negative pulses, you have to take it as the condition. Take the condition. Then you have to check the QS. See here. Negative clock, where it will start? Here. See my cursor. Positive pulse ends, negative clock starts. Yes or no? See 0, 1, 0 positive pulse. 1, 0, 1 negative pulse. See the cursor where I put, is it positive pulse or negative pulse?
Negative pulse.
Negative pulse. As I told, QM is the S for the slave. QM bar is the R for the slave. What is QM? Cursor timing you have to see and tell me the value of QM. What is QM?
1, sir.
1. What is QM bar?
0, sir.
0.
Hey, what is QM first? QM is 1. What should be QM bar?
0, sir.
0.
0. QM is J. QM bar is K. Which case is this one?
Set case.
Set case.
QM is J. QM bar is K. QM is 1 and QM bar is 0. Which case is this one for JK?
Set case. Set case.
Retain, set, reset, toggle.
Set.
Set case, sir.
Hey, which case is JK? JK 00 is retain. JK 10 is set. JK 01 is reset. JK 11 is toggle. Which case is this one?
Set case.
Set case, sir.
Set case. Now you see. QS is the output of the, see QS is the output of slave. Slave was 0. At the negative pulse, slave changes to 1. Slave is set. Slave is set. Check here. Slave is set. Master will take J and K are the inputs with the positive pulse edge which it will change the output. Then when negative pulse starts, QM and QM bar are the master outputs or slave inputs treated as S and R. Then in the slave period, pulse period, that is negative pulse period, QS changes similarly till the last. Then what best I can say here is, this is the waveform. S and R are the inputs. It's okay. With the clock 1, which it will take and provide the output QM and QM bar. And this QM and QM bar, slave will take it as S and R. But the negative pulse, which it will provide the output as QS and QS bar. With one cycle, takes the input JK and provide it the output as QS and QS bar. This is the waveform for the master slave flip-flop. It's okay. Then the question is, once again, I can repeat in the beginning, SR is a problem for forbidden, has to be overcome by JK. It's okay. Then JK11 case, I am not getting a forbidden or invalid case. I am getting the toggle output. It's okay, toggled output. But the toggling is once again a problem. It is a continuous toggling, even though pulse will be with some high period. Then that is not good. That I need only either logic 0 or a logic 1 toggle. Then which you can improve with the master slave flip-flop. It's okay. Then what exactly the toggling name is there? What is the toggling name continuously in 1-1 case of the JK? Array surround condition. That array surround condition is overcome by the master slave flip-flop. Okay, with this today class will conclude. It's okay. And if you have any doubt, you can ask. 1 second there.